Take a deck of cards fresh out of the box in perfect factory order and give it 3 good, honest riffle shuffles. Now pull off the top card, look at it, and bury it anywhere you like in the middle of the deck. That card feels lost, one stranger among 52. But hand me the deck and I can find it every single time. No sleight of hand and no marked cards. A deck shuffled 3 times is simply not random, not even close. Plot the deck's distance from random after each shuffle. Nothing happens, then a cliff. Here is why. First, let's agree on the rules. A riffle shuffle cuts the deck roughly in half, then weaves the packets together. And random means something strong. Every possible ordering of all 52 cards is equally likely. No arrangement is special. How many orderings are there? An 8 followed by 67 zeros. More than the atoms in our galaxy. Every well-shuffled deck you have ever held was almost certainly an arrangement no human being had ever seen before. So the question is this: after a few shuffles, is every single one of those orderings really equally likely? Watch what one riffle can and cannot do. The cards from each packet spread out, but they stay in order. A shuffle weaves, it never reorders. So one shuffle always leaves 2 rising threads woven through the deck. Shuffle again and each thread gets snipped into 2. 2 threads become 4, then 8. Each shuffle doubles the threads. But a truly random deck carries about 26 threads. After 3 shuffles, you have at most 8. So a lightly shuffled deck is not just improbable, it is the kind of object that randomness almost never makes. Which explains the card trick. Your buried card is an orphan. It belongs to none of the long threads. Deal through the deck and the cards sort themselves into runs. One card belongs to nothing. That one is yours. You can even turn this into a bet. Guess whether a deck is shuffled or random just by counting threads. For 4 straight shuffles, that bet never loses. That is why the graph stays pinned at the very top. At 5 shuffles, the perfect tell dies. At 6, your edge shrinks. At 7, it collapses. In 1992, 2 mathematicians traced the dovetail shuffle to its lair and found one astonishing formula. The chance of any arrangement depends on just one thing: how many rising threads are woven through it. From that single formula, the whole cliff falls out. For 52 cards, the drop lands at 7 shuffles. And bigger decks make the cliff sharper, not smoother. 1,000,000 cards would need about 30 shuffles. Mathematicians call this the cutoff phenomenon. Randomness does not seep in gradually. It arrives all at once. That is the real lesson. Randomness is not a substance you pour in. It is the death of every pattern. And patterns do not fade politely. A structure is either detectable or it is gone. The transition is a cliff. A vague question became a precise one the moment we found the right thing to count. So here is your homework. Shuffle a deck 4 times and count the rising threads yourself, 16 or fewer, every time. And when someone tells you 7 shuffles is enough, you will know the better secret. Why?